Imagine a force so vast it could obliterate 1,000,000,000,000 suns in a heartbeat, or a power so subtle it shapes every atom in your body. Hidden champions of the cosmos await. Now, step into Before the Light, where we unravel these mysteries. Tonight, we're embarking on a quest to uncover the universe's mightiest force, from stellar explosions to the fabric of reality itself. Get ready, the journey begins now. Deep within every atom, a hidden battle rages that shapes the very building blocks of existence. Picture this: protons, packed tightly in the nucleus, should explode apart instantly. Their positive charges repel each other with a force like trying to shove two powerful magnets together head-on. Yet, against all odds, they stay locked in place. What holds them? The strong nuclear force, a power so immense it's considered the universe's strongest player. Scientists measure it as 100 times mightier than electromagnetism, and a staggering 100 trillion times stronger than gravity. Imagine gravity as a faint whisper. This force is a thunderclap that could shatter mountains. This incredible strength comes from tiny particles called gluons acting like invisible chains. They bind quarks together to form protons and neutrons. Here's the wild part. The more you try to pull these quarks apart, the stronger the force gets. It's like stretching a rubber band that thickens and fights back with every inch. This bizarre behavior, known as confinement, means you can never isolate a single quark, no matter how much energy you throw at it. Inside each proton, 3 quarks dance in a prison of pure energy, their gluons weaving a complex web so intricate that even our mightiest supercomputers struggle to unravel it. When you attempt to separate them, the energy you add doesn't free them. It creates new quarks and gluons, like cutting a chain only to watch it grow new links. This force operates on scales so tiny, a femtometer, or 1/4,000,000th of a meter, that our everyday physics crumbles. Space and time turn uncertain, ruled by the strange laws of quantum mechanics. This power doesn't just hold atoms together, it dictates which nuclei can exist, sets the pace of star-burning fusion, and balances creation and destruction in every stellar heart across the cosmos. Without it, protons would fly apart, nuclei wouldn't form, and the universe would be a lifeless haze of hydrogen and free electrons. Yet its reach is limited, stretching only to the edge of an atomic nucleus, about 1/10,000,000,000th the width of a human hair. Beyond that, other cosmic giants take the stage, far beyond our world, in the depths of a remote galaxy billions of light years away. A cosmic drama unfolds with breathtaking fury. A star 100 times more massive than our sun reaches the end of its life. For a fleeting moment, it unleashes a cataclysmic blast, more energy than 1,000,000,000,000 suns combined, sending shockwaves rippling through space-time itself. This is a gamma-ray burst, the universe's most ferocious explosion, and it's about to steal the spotlight. These titans are born when the universe's heaviest stars, packing 20 to 100 times the sun's mass, burn through their nuclear fuel at a breakneck pace. In just a few million years, blinking fast on a cosmic scale, they exhaust their reserves. Gravity wins the ultimate battle, collapsing the core into a newborn black hole. But the story doesn't end there. As the core implodes, it fires twin jets of matter and energy from its poles, racing out at 99% the speed of light. Magnetic fields, twisted and amplified by the collapse, act like cosmic cannons, launching these beams with pinpoint precision. They punch through the dying star like bullets through paper, emerging as focused pillars of destruction that hold their shape across unimaginable distances. Think of a laser beam staying sharp from Earth to the nearest star, but on a scale millions of times larger. The power is staggering. A single gamma-ray burst can outshine 1,000,000,000,000 stars, glowing brighter than the full moon if we could see gamma rays with our eyes, even from galaxies billions of light years away. In just 10 seconds, it releases more energy than our sun will produce in its entire 10 billion year lifetime. The most extreme example, nicknamed BOAT, brightest of all time, struck in October 2022. This monster, detected from 2 billion light-years away, was so intense it saturated gamma-ray detectors across the solar system and even triggered detectable changes in Earth's upper atmosphere. Picture this. Standing on our planet, you'd see a flashlight beam from Alpha Centauri shine like a car headlight. That's the scale of its might. This light, traveling for billions of years, carries echoes from when the universe was young, when stars were more massive and violent than today. Some bursts, spotted from distances so vast their light began its journey less than 1 billion years after the Big Bang, offer glimpses of the early cosmos. These ancient explosions didn't just destroy, they seeded space with heavy elements, the building blocks of planets and life. Gamma-ray bursts may be brief, but their legacy echoes through the stars. Step into the shadows between galaxies where the universe's most relentless predators lurk. At the heart of our Milky Way sits Sagittarius, a star, a black hole 4 million times more massive than our sun, devouring gas clouds and star systems with insatiable hunger. But this is just a warm-up. True titans dwell deeper in the cosmic void. Some supermassive black holes, like the one in galaxy M87, pack the mass of 6 billion suns into a region smaller than our solar system, turning space into a gravitational maelstrom where nothing, not even light, can escape once it crosses the event horizon. These gravitational monsters don't grow slowly. The farthest quasars, shining from when the universe was less than 1 billion years old, are powered by black holes that somehow balloon to billions of solar masses in what feels like cosmic minutes. How? One leading theory suggests they began as massive seeds, huge gas clouds collapsing directly into black holes, with hundreds of thousands of solar masses from the start. This head start let them feast on surrounding matter and merge with others, growing into the giants we see today. As gas spirals inward, friction heats it to millions of degrees, forming an accretion disk that glows brighter than 100 billion stars. This disk spins so fast that matter near its edge stretches time itself, turning seconds into hours for outside observers. The real spectacle? Quasar jets, beams of superheated plasma launch from the black hole's poles at nearly light speed, stretching hundreds of thousands of light years. Magnetic fields, twisted by the disk's rotation, act like cosmic accelerators, channeling this energy with precision no human tech can match. These jets carry enough power to reshape entire galaxies, heating gas clouds to millions of degrees and halting new star birth across vast regions. Some jets, active for millions of years, leave scars in space visible even now. Recent observations reveal black holes so massive they defy the usual link between their size and their host galaxies, puzzles that challenge our understanding of cosmic evolution. Black holes may be silent, but their reign is anything but quiet. Beyond the reach of black holes, an invisible power reigns supreme, reshaping the cosmos on a scale beyond imagination. Meet dark energy, the mysterious force that makes up 70% of everything in the universe. Every second, it pushes galaxies farther apart, stretching the fabric of space-time itself in a relentless expansion. Unlike gravity, which pulls things together, dark energy acts like a cosmic gas pedal, accelerating this growth. The bigger the universe gets, the more dark energy seems to fill the void, growing stronger as space expands. Scientists stumbled upon this enigma in the 1990s while studying distant supernovae. They expected the universe's expansion to slow down, tugged back by all that matter. Instead, they found it speeding up, a shocking twist that revealed dark energy's dominance. Picture the universe as a balloon being inflated by an unseen breath. Every point on its surface drifts away from every other, galaxies riding this swelling ocean with no way to fight the tide. This force doesn't weaken with distance like gravity or electromagnetism. It defies the rules, hinting it might be a property of space itself, a concept Einstein once proposed and later called his greatest blunder. But the future looks grim. Dark energy's power could lead to a big rip, tearing apart galaxy clusters, then galaxies, and eventually even atoms themselves. Stars would fade, planets would drift, and the building blocks of matter would scatter across vast distances. Where this extra energy comes from remains a mystery. Some think it's a constant, others a dynamic field shifting over time. Whatever it is, dark energy holds the key to the universe's fate. A silent force with a voice that could unmake everything. Take a step back to the beginning of it all, 13.8 billion years ago, when everything we know was crammed into a point smaller than a proton. This was the Big Bang, a singularity where all matter, energy, space, and time were born in a single, unimaginable burst of power. In that first fraction of a second, tinier than the blink of an eye, at 10 to the negative 35th power seconds, the universe exploded outward faster than light itself, a period called cosmic inflation. This rapid stretch grew space by billions of billions, setting the stage for everything that followed. At that moment, the laws of physics as we know them dissolved. Temperature and density hit infinity, and the four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were fused into one unstoppable power. As the universe expanded and cooled, this unity shattered, releasing energy that shaped reality. Within the first minute, protons and neutrons fused in a cosmic forge, birthing most of the hydrogen and helium we see today through a process called nucleosynthesis. For 300,000 years, the cosmos was a glowing fog, with free electrons scattering light until the first neutral atoms formed, letting light stream free as the cosmic microwave background, a faint echo of creation still visible today. This wasn't an explosion into space, but an explosion of space itself, crafting time and the rules that govern our world. No event since has matched its power to conjure everything from nothing. Yet the exact mechanics of that unified force remain a mystery, a puzzle scientists are still piecing together. The Big Bang wasn't just a start, it was the ultimate spark that lit the cosmic fire. Venture deeper into the cosmos where relics of the universe's birth and its most violent deaths collide in a display of raw power. Imagine cosmic strings, invisible threads thinner than a proton, yet packing the mass of Earth in just a meter. Born during the Big Bang's first fraction of a second, these one-dimensional scars mark where space-time crystallized differently as the universe cooled. A string from Earth to the Moon would hold energy to power humanity for trillions of years, concentrated in a line with no width. If they move, they ripple space-time, sending gravitational waves detectable by our most sensitive tools. When two strings cross, they form loops that vibrate like cosmic guitar strings, gradually shrinking and vanishing in bursts of distortion, potentially offering shortcuts through folded space, though that's still a dream. Then there's the Hypernova, a stellar explosion that dwarfs even supernovae. Triggered by stars 50 times the sun's mass spinning rapidly, these monsters collapse into black holes, unleashing 10 to 100 times more energy than a typical supernova. The core's implosion spins an accretion disk, generating magnetic fields that launch jets at 99.9% light speed, drilling through the star like cosmic jackhammers. These jets trigger explosive fusion, turning carbon to iron in seconds, and forge heavy elements that seed the galaxy. A single hypernova can disrupt star formation across millions of light years, its shockwaves a testament to nature's fury. Both cosmic strings and hypernovae hint at powers from the universe's wild youth, ancient might still echoing today. Now push the boundaries of reality itself. Beyond our universe lies the multiverse, an infinite ocean of possibilities. In this mind-bending realm, our Big Bang was just one of countless explosions, sparked by quantum fluctuations triggering eternal inflation. New universes bubble up continuously, each with its own laws of physics. Gravity might be stronger, electromagnetism weaker, or elements unimaginable here. Some expand forever, others collapse in big crunches, while others cycle endlessly. This idea stems from quantum mechanics, where every event with multiple outcomes splits reality into parallel branches. The anthropic principle suggests we see our universe's rules because they allow us to exist, even if rare. If communication between universes were possible, we might tap infinite knowledge, though that's a leap beyond current science. The multiverse's total energy could be infinite, making it the ultimate expression of cosmic power, where every possible history and law plays out somewhere. It's a theory that stretches our minds, hinting the universe's might not end with what we can see. We've journeyed across the cosmos, from the strong nuclear force binding atoms to gamma-ray bursts lighting up the void, from black holes warping space to dark energy stretching it apart, and beyond to the Big Bang's fiery birth, neutron stars' magnetic might, cosmic strings' ancient echoes, hypernovae's fury, and the multiverse's infinite possibilities. Each force has claimed its crown, each a titan in its realm. But perhaps the true power lies not in destruction alone. Consider this: the calcium in your bones, the iron in your blood, the gold in your hands, forged in the hearts of exploding stars and scattered by dying giants. You are made of stardust, assembled by forces that have shaped worlds for 13.8 billion years. The universe didn't just create matter, it crafted complexity, beauty, and awareness. Its greatest triumph might be us, conscious beings pondering our own origins. Every quantum fluctuation, every galactic collision played a part in bringing you here to marvel at the cosmic dance. So what's the most powerful thing in the universe? Maybe it's not a single force, but the universe's boundless creativity, turning simple hydrogen into stars, stars into elements, elements into planets, and planets into a stage where life can emerge to understand it all. Join before the light again to explore more wonders. Like, if you're amazed, share your thoughts below and let's keep decoding the cosmos together.